Everyone, welcome to the next video of C programming. In the previous video, we have learned the basics of array, why array is required. If you'll fix your ideas, then we can discuss like array is nothing but it's a collection of similar type of elements. And the first element in the array is indexed as 0. So the last element is obviously one less than the size of the array. An array is also known as a subscripted value. So before using an array, it is compulsory to declare its type and the dimension. So whenever the array is very big, the elements are always stored in contiguous memory location. Okay. So these are the things we have discussed in the concept of array. And also we have discussed different types of arrays there. So in this video, we'll discuss one of the type, that is your 1D array. So 1D array means one dimensional array. Okay. So, and also if you think array is nothing but it's a very popular data type. Okay. So this is what the different types of initialization of the array. So that means array can be initialized by using static. Array can be initialized by using the process of dynamic initialization. Okay. Static initialization, all of you know that whenever you have declaring the variable, during the declaration time, you are assigning the value. That is known as a static initialization. And dynamic initialization is all about using the concept of scanf, or the user is taking the input from the keyboard. Okay. Now let us discuss one by one regarding the example. So there are various types of declaration. In some of the declaration, if you are not providing the dimension, then it will allocate the memory whatever the number of values you have assigned. Like in this example, you have assigned 5 values. So first of all, what will happen when the array will be declared according to the number of values, that many number of memory blocks will be assigned to you. Okay. The index will start from 0, 1, 2, 3, and 4. Sequentially, the values will be stored 11, 22, 33, 44, and 55. So as you are assigning 5 values, so the dimension will be 5 automatically. Okay. But you have to remember, whenever you are declaring any array, then the dimension is a must. If you are not providing dimension, then you have to go for static initialization. Okay. Now the second category, here we are providing dimension 3 and you are assigning 3 values. So what will happen? Now 3 blocks will be given to you. Okay. And sequentially the values 11, 22, and 33 will be stored. Clear? Third category, you have requested for 5 blocks. So as for the request, 5 blocks of memory will be allocated to you. Okay. So 0, 1, 2, 3, and 4. Values will be stored 11, 22, and 33. The rest of the blocks will be stored with 0. Done. Now, if you are initializing 5 or you have requested for 5 blocks, but you are assigning a single value, okay, now all the blocks will be associated with 0. Okay. Now, the last one, which is of 3 size, but you are mentioning or you are assigning 5 values. Clear? So here you will get some error message during the execution time. Clear? That means only 3 blocks are allocated to you. So you can store only 3 values, but for the rest of values, you have not specified the memory location. You have not requested. So you are not allowed to store the values. This is what the different type of static initialization. But in general, whenever you will write program, you will go for dynamic initialization. That means you have to ask the user during the execution time what value you want to store. It's not that you are fixing the values. In the entire program, these values will be fixed in the array, but that is not our requirement. Our requirement, the user will give the input and accordingly the values will be stored. Okay. So let us see how actually we'll write down the program or initialize dynamically. Okay. So you are giving the header file. Now what you have learned in this 1D array or array video, you have to specify the type of the array name, and the dimension. Okay. So whenever you are declaring array of 5, so in the background, what will happen? Now you are requesting for 5 blocks of memory. So what will happen? So 5 blocks will be given to you if the memory is available. Okay. Index will always start from 0, and we have told that the last index is always one less than the requested size. Okay. So if you consider the memory allocation, if the starting block is 1000 and it is of integer type, so that means every block is capable of storing one integer value. So the size of each block is 4 byte. So the next block will start from 1004. This will be 1008, 1012, and 1016. And the name of the array will be ARR. Okay. This is what actually in the background it will happen. Okay. Done. Now, how we'll access the values? Clear? So the first approach, we can enter the value one by one. Okay. So in scanf, we need the address. So what is the address? Address is 1000. How to access 1000? Now I can write array of 0. Okay. Means what? If I am writing array of 0, means the value at 0 index. Okay. But if I'm writing ampersand array of 0, that means address of index 0. Okay. So in scanf, we need to specify the address. So we are specifying the address of 0. Okay. The same statement I have to write how many times? 5 times. Okay. Because index by index, I will assign the value till 4th index. Okay. If you are assigning the value one by one, then I have to write down the number of times the block is being assigned. So I have assigned 5 blocks of memory. So I am writing 5 times to take the input. Okay. Similarly, while printing the value, printf percentage %d array of 0. Okay. Now to keep a space between the values, let us give a space here. So this is what you are accessing the value. What you have written? Array of 0 means value at index 0. So you are printing the value at index 0. Same thing. I have to print 5 times. Okay. One for this one for the third index, one for the fourth index, and one for the last index. Okay. So one by one, I am printing the values. So let us put a message here. Values of array are. Okay. So array demo. Let us compile and execute. We don't have any error. So it is asking for value. Okay. So I'm entering suppose 11. This is the first value, second value, third value, fourth value, and fifth value. Because I am being given that 5 blocks of memory is assigned. So 5 blocks will be there. So the values will come as 11 will be stored at 0 index, 22 at the second, 33 at the third index, 44 at the fourth index, and 55 at the fifth index. Okay. But whenever you are printing the value, again, I am going for array of 0. So the first value will be printed, that is 11. Now the second value, array of 1, 22. Third value, array of 2 I have printed. Fourth value, so array of third I have printed. The fifth value, array of fourth index I have printed. Okay. So this is how you can access the values one by one as per the requirement. Okay. But the problem is here what? Now we have learned a particular concept where I can avoid the repetition of code. The same code I am writing repeat again and again. Okay. So how to avoid the repetition of code? Now we know that we can use the same concept in loop. So I am not modifying the program. I am rewriting the program once again. So I'll just write down these two lines. Why? Because I am repeating the code. Okay. So I'll not repeat. What I'll do? Now everywhere, what is changing? The index is changing because one is for 0, one is for 1. Okay. So what I'll do, I'll write down a loop here, index equal to 0, index less than 5, index plus plus. Why? Because I know that the index of array starts from 0 and it will go 1 less than the size. Okay. And these two lines I'll write down inside the loop. Okay. But what I'll write down here? I'll write down index. Okay. Now let's execute index equal to 0. So once index will be 0, so it will come 0 less than 5 true. Enter. So whatever the value will give, it will go to array of 0 index. Next time index will become 1. So next time the value will go to address of array of 1. Next time it will be 2, so it will be 2. Next time it will be 3. Next time it will be 4. When the index will become 5, 5 less than 5 is false, so it will come out. But before coming, it will take the input 5 times into different index values from 0 to 4. Okay. Now, the same thing I can do here also because I am repeating the code again and again. And what is the change here? Only the index number. So while write down again and again, I'll again write inside the loop. What loop I'll write down? Now whatever I have written for the input, the same I'll write down index equal to 0, index less than 5, index plus plus. Okay. And inside that, I'll write down this printf statement. Here in place of 0, I'll write down index. Okay. Understood? Now let us compile and execute. No error. Values 11, 22, 33, 44, 55. 5 times the loop will continue. 5 values it will take input. After that, again the loop is continuing. So loop is coming from 0 to 4. So all the values are printed. So this is how you have to take the input into the array and you have to display the values of the array. Okay. One more thing, I can modify this particular program. Like I have declared here as 5, but in between the program, if I need more than 5, then some problem may occur. So what I'll do, I'll be in the safer side. I'll declare the size as 50 because I don't know my requirement. Okay. But my requirement always comes whenever I'll execute the program. So what I'll do, I'll ask the user, enter the total number of values you want. Okay. So during execution, definitely I'll know that what is the total number of values I can utilize. So what I'll do, I'll take the input from the user and that I'll store in the size variable. Okay. That means I am not fixing or keeping it as static that only 5 values I can operate. I can operate as per my requirement. Whatever the total size value I'll take, in place of this 5, I'll write down size. Okay. So that means maximum 50 values I can access. I can access 5, I can access 10, I can utilize 15, 20, 30, whatever, but maximum 50. So as per my requirement, I'll give the input to the size variable and then I can access. So let us compile and execute. Now see, it is asking, before operating, it is asking how many values you want. Now I want 7 values. So 10, 20, 30, 40, 50, 60, and then 70. Now you see 7 values I can operate. If I want, I'll run once again. It is asking, I'll add on 3. So that means 12, 67, 54. 3 times the loop will continue. So that means this is what my final stage of writing program of array, that I can declare one size of the array, and then accordingly I can operate the total array concept. Okay, so through this video what we have learned the different types of accessing initialization of one dimensional array. And the best part is, through static initialization we can fix the values, but through dynamic initialization I can provide the value from the user during the execution time. Also, I can take a larger size of the array, and then I can take the input how many number of values actually I want to operate. So my loop will execute on the basis of that concept. Okay, so in our next video we will write some more programs on array so that you can understand the concept of one dimensional array. Okay, so thank you everyone for watching this.